So we have seen that these electric field lines are in 3D, and as we move further and further, the strength of these field line decreases as each proportional to 1 by r square, decrease as 1 by r square, and I had explained in the last video how that has been done. So now you have to read this story or this paragraph about this, and they have also explained the same thing in a different method, but you must go through this. So now, how this electric field lines picture was developed? It was developed by Faraday to give a feel that how does this mathematical things work, to visualize these mathematical things. Electric field lines around charge configuration, because previously if he was saying anyone that there are field lines, they were not able to imagine those. Faraday called them field lines of force. What did Faraday call them? Field lines of force, but this term is somewhat misleading, especially in case of magnetic fields. The more appropriate terms is field lines, hence we use electric field lines or magnetic field lines. So again, if you understand this concept, this will help you in understanding the magnetic field lines as well. So in a way, you understand that from a positive charge, electric field lines goes outward, and there are spheres. If we keep solid angle fixed, the number of electric field lines in that solid angles remain fixed, no matter what is the distance from the source of those electric field lines. Or if we keep the area constant, so the number of field lines passing that fixed area will reduce as we move further and further. How? As proportional to 1 by r square. So this is a major concept related to electric field lines, and there might be a question on this. So here you can see that they have shown some patterns for electric field lines. So here it is for q greater than 0, that means charge must be positive. So point charge is there and electric field lines are going outwards. But for a negative charge, these are coming inwards. How? Radially inwards. These are either radially outward or radially inward. Okay, so till now you have understood few concepts related to these electric field lines, and their strength is, as you see here, the strength is low, here strength is more in the same area. So now you have understood the concept related to field lines. Now let us understand some general properties associated with these. The field lines follow some interesting general properties. What are these properties? Let us see this. In the second case, here you can see that q is less than 0, that means this is negative, here it is positive charge. This question might come in 1 mark, that please draw the electric field lines for positive as well as negative charge, or a variation of this, What kind of variation? See here, two positive charges are brought closer. If you see that as we brought second positive charge, so for the first charge the field lines were like this, normally radially outward like this, but as soon as we brought second charge closer to this first charge, so these field lines are now curved, so they don't intermingle or they don't mix up with each other. So the field lines don't mix up with each other, and the resultant will be something like this. Okay, so this figure or this diagram could come in your exam, so please understand this concept. Now here we see two positive charges. If there would be two negative charges, there would be a similar pattern, only the direction of field lines is radially inward. Instead of radially outward, this would be radially inward. But what happens if there are one positive and one negative charge? Then electric field lines would make a closed loop. These are closed loop. See, these electric field lines are going from positive to negative and making closed loop. And also also in the few examples back, in numerical example, you saw that the electric field was going from positive to negative side. Why? It is radiating outward from positive and radiating inward to negative side. So direction of electric field or electric field lines are always from positive to negative. Here you are seeing the same. These are going from positive to negative. Since both the charges are same, so hence they are forming closed loop. Okay, so now let us understand few properties associated with these field lines. First property, field lines start from positive charge and at any negative charge. Okay, so these starts from positive charge and ends at negative charge. If there is a single charge, they start or end at infinity. So what does that mean? So if there are positive and negative both the charges, so field lines start from positive charge and end at negative charge. If there is no other charge, that means either positive or negative charge, field lines start from that point and will go to infinity, or field lines come from infinity to that point, depending on nature of charge, negative or positive. So this is first property associated with these field lines. Now second property, in a charge free region, that means there is no charge, electric field lines can be taken to continuous curve without any breaks. See, if there is no other charge, these lines can be go up to infinity without any breakage. Like here there is no breakage. See, this is a break, but do you see any break here in these lines? No. So these go up to infinity in a charge free region up to infinity, or these are coming from infinity to this point without any break. What would be a break? A break would be something like this, but there are no breaks in these. Okay, so there are no breaks in these electric field lines. Third property, two field lines can never cross each other. So this is very important. Two field lines can never cross each other. If they did, the field at point of intersection will not have a unique direction, which is absurd. Absurd means it cannot happen. So here you can see either you take positive charge or negative charge, but field lines are not intersecting. These are always going outwards and they will never meet each other. In fact, the distance between them is further increasing. So field lines never intersect each other. Same in case of negative charge. If both the charges are positive, again you see no two lines are intersecting each other. At this point these are concentrated, at this point these are further apart, but still they are not intersecting each other. And if we go to this diagram again, they are forming a closed loop like this. These are closed loop, but again no field lines are intersecting each other. No, not in any case, whether positive charges, negative charges, single charge, multiple charge, field lines never cross each other. Electrostatic field lines do not form any closed loop. This follows from the conservation of nature of electric field. So what they are trying to say, that electrostatic field lines do not form closed loop. So here what I have shown a closed loop, and you are saying, what I am saying, that they are not forming a closed loop, but for a single charge they are extending up to infinity, but for a multiple charge they form a closed loop. Okay, electrostatic field lines form a closed loop only for a positive and a negative charge, while for magnetic field lines one side is north, another side is south, so they form this kind of closed loop, or even with a single type of magnet. But electric field lines don't form closed loop. They form closed loop only when there is a one positive and another negative charge. But for a single charge, there is no closed loop. It goes up to infinity.